Hey, good afternoon, everyone. We had an exam number one, the midterm number one yesterday, and I just finished correcting. It was not so good. I would like to go over the exam here with you, and um, and I think my idea is so when we do midterm number two, I will um, offer you the chance of um, revisit some of these questions that we focus on midterm number one. It's not going to be the same exam, but something kind of a close to it. And then let's see how you now understand the subject. But basically, I will go back to a group of 10 questions, pretty much similar to the questions we have here. And I just want to know if you guys are now um, stronger in describing possible answers. Remember, this course is a descriptive astronomy, so you have to be able to describe things. And I know when we assess the students in this course, in general, we use multiple choice questions, and all the description is done in the multiple choice questions themselves. So the students really don't say anything because they just mark a possible answer. So this is a little bit more challenging for you because I want you to be able to say things. Um, so which means when we do midterm number two, make sure you review those questions and you understand what's going on. But for now, let me go over the exam itself. By the way, a few students also miss midterm number one, so those students will have the chance of then um, get some grade on the missing exam. So let's go to exam number one. And question number one, assume the moon is rising today that's centered on the constellation Virgo. So which means, let's say the moon is right here, right? It rises on Virgo. And the question is, um, so we have Virgo here, we have Libra, and we have Leo, Cancer. So we have the zodiac kind of going like this. We can conclude that the moon will be setting today in which constellation? So if we remember the process of rising and setting, and here let me see. In fact, let me go a few days in advance. Just want to have the moon somewhere here. There you go. The moon. See the moon passing? There you go. So this is Sunday, and the moon is here, right? So if I bring daytime again, that's what we got. So we have a moon in a waxing, probably crescent phase. Yeah, certainly crescent phase. And so let me give the daylight just so we know what's going on. And let's change this to minutes. And in fact, that is not it. That's not real motion. Okay, so I'm just trying to bring the moon to a rising moment here. Okay. Stop there. Okay, so the moon is about to rise. It's 10:57 a.m. and we have a moon in a waxing phase. And let's see which constellation the moon is now. Boundaries. Labels. And where the moon is? The moon is in Orion. So the moon is in Orion. The moon is in the constellation Orion. See in that little corner? So the moon rises in Orion. And if we speed up time, by the way. So stop there. Oh, stop it, stop it. So I have to go back again. Sorry about that. So the moon was setting in, well, in kind of in Orion too. I mean, in respect to the stars, the moon does go a little bit to the left in respect to the stars. So, but if the question there was that center in Virgo, remember? So the constellation that was in place was Virgo. So Virgo is a big extent. So if you put the moon here, I don't know when the moon is going to be here. Let me see if I can set the moon there sometime in the future. That's good enough. So on April 10, 2017, moon is going to be that center in Virgo, right? So then you can see clearly in respect to the whole constellation, the moon does not change much. You can see the moon is going slightly left and it's slightly going over the letter G and now slightly going to the letter R, but it's rising in Virgo and setting in Virgo. It doesn't change much. Certainly in about, if we go back and allow next day to come by, this is not going to be the case. Taurus, Orion, and then Gemini, Cancer. Let me increase here the time flow. So the moon is going to be a little bit more to the left in Virgo. See? So that probably, if the moon is here, if I had asked this question to you, probably it would be setting Libra. Look at that. Probably. See that? Because in fact the moon changed position in the sky in respect to the stars slightly eastward, and in fact is about 12 to 13 degrees a day. 12 to 13 degrees a day. And because of Earth rotation, the sky itself all move westward about 15 degrees an hour. So it's funny, the first question, no one got it right. So let's go to the second one. What is a celestial sphere? Celestial sphere is an imaginary sphere. It's not a real one, but it's an imaginary sphere that we, in fact, ancient philosophers thought the Earth would be surrounded by it, and stars would be in it. And as these spheres circulate and rotate around Earth, it would bring with it all the stars in it. But then they realized that planets, or those wanderers stars, didn't seem to be obeying the motion of the celestial sphere, and then they created spheres for each of the planets, and those extra spheres would be moving in respect to the celestial sphere. So, but your answer should be, well, celestial sphere is something that does not exist but help to, locate stars, to give position and things like that. What argument would you provide to a flat Earth person to convince that Earth is spherical? Well, you could, it's not because you see the sun in different positions in the sky. So when you say that, you're not saying much, because the sun does change position in the sky, as we see on an hourly basis because of Earth rotation. So that doesn't explain flat Earth in a way. So if you had Earth like a big plane, a big flat thing, And if you had the sun kind of moving in the sky somehow, and if Earth were a flat thing that were finite, I mean, the sun would just, go around this flat thing and would change position. What it does indicate this Earth is somewhat spherical is by longitude. No, I'm sorry, by latitude. So let's say if you communicate with somebody, same longitude, but different latitude, like you talk to somebody in South America, right? And you are here in California, and that person should be at the same longitude line, but different latitude. So when you talk to that person, ask that person what the sky looked like, and it's going to be different. And then you can kind of infer that Earth is spherical. Another one is the ship. You are in a cliff and you see a ship kind of going away and slightly disappear in the horizon. That's another one. Another one is, well, if you have space technology, you can take a picture and show the Earth is spherical, although the conspiracy theory people might come and say, oh, you have fake news or fake pictures, right? So there is always some counter argument, but there are different arguments. Shadows. So somebody answer, in fact, more than one student answer that solar eclipse proved that Earth was spherical. Solar eclipse doesn't. It might prove that Moon is spherical, but not that Earth is spherical. Now, lunar eclipse might prove that Earth is spherical because you see Earth shadow being cast on a full moon. What arguments, that's number 3. Number 4, describe the main difference between geocentric, heliocentric, Keplerian, Galilean, Newtonian worldviews. So the geocentric worldview is one that Earth is in the center of the universe and you have planets going around Earth in deferent ellipse cycles, if you remember that well. But basically, Earth is in the center of the solar system, and the planets and the sun and the moon goes around Earth, and also the celestial sphere with all the stars. The heliocentric worldview is different. Now the sun is in the center of the solar system with planets going around the sun, revolving around the sun, and so, but it's the revolution of planets around the sun is done in a circular way. And that's the main problem with Copernican heliocentric worldview, is because the motion was still a circular one. So you had the sun and you have planets going in circle. Mine is not a good circle. So to make things work as far as observation is concerned, the Keplerian worldview also, not Keplerian, the Copernican worldview also introduced epicycles to help improve precision. Now, in Kepler found its 3 laws of motion. And the first law of motion is planets go around the sun in elliptical path, and the sun happened to be in one of the focus points. So there are 3 laws of Kepler, and Newton later on came and was able to create a law of the universal gravitational law that account for this elliptical path. Give examples of how Earth rotation. So Earth rotation. So Earth rotation on its axis of rotation give rise to days and night. Right? That's the basic one. And pretty much that's it. So if you think about revolution around the sun, revolution has nothing to do with day and night. So if Earth were not rotating on its axis of rotation, we would have a day of about half of an year and a night of a half of an year. This is not the case. We have day and night in 24 hours because of Earth rotation. Now, Earth revolution and because of tilt of Earth axis of rotation implies that we have seasons implies that we see different constellations. This is not because of tilting. So constellations in the sky, different constellations in the sky arise because of revolution. Please review this in your book because very few of you got this right. Zenith is the point exactly straight up on anybody on Earth. So you have somebody standing right here. Zenith is in that direction. For somebody standing right here, zenith is along that direction. Celestial equator is a circle in the celestial sphere that is defined by extending out Earth equator onto the celestial sphere. The north celestial pole is in the celestial sphere, the point extreme north, and is defined by extending Earth axis of rotation towards the celestial sphere. Equinox points to something interesting about it, and that is when the sun ecliptic meets the celestial equator and defines the equinox points, the fall and vernal equinox. The vernal equinox is when the sun is moving north, and fall equinox is when the sun is moving south. And as far as Earth is concerned, during fall and vernal equinox, both hemispheres receives the same illumination. I was expecting more of you getting this right. So new moon and then full moon, right? And then you go as looking north on the system Earth, Sun, and Moon. The new orbit Earth in a counterclockwise direction, and from new to full it goes the waxing phase. The full to new it goes the waning phases. Crescent phases are somewhere here. Gibbous phases are somewhere there, and pretty much that's it. The quarter phase would be here. That's first quarter and last quarter right there. Explain retrograde motion. So retrograde motion is the apparent motion of planets in respect to the stars. In which case, if we are talking about retrogrades, the planets seems to be moving westward in respect to the stars. Example, you have a tortoise. You have tortoise region with the bright stars that make up the tortoise phase with Aldebaran in there, and you see Mars somewhere here, right? Now, in respect to these stars, a few days later you see Mars here. So a few days later you see Mars there. So Mars is prograding because in respect to the stars, the Mars is going from west to east. This is prograde motion. Now, if later on we see Mars kind of going backward, which means it went from this position to that position, we call this sequence of configuration retrograde. So it's the apparent motion of planets with respect to the background stars from east to west, like this. Explain seasons. Seasons is caused by, it's not by the proximity of Earth in respect to the Sun, but is caused by Earth axis of rotation being tilted in respect to the ecliptic plane. So if the Sun is located right here, during summer solstice in the north hemisphere, this is north hemisphere, the north hemisphere happens to be tilted towards the sun, and we call this summer in the northern hemisphere, and winter, same time, winter hemisphere. Okay, and so I did a craze thing here. Put the sun orbiting Earth. How could I? Sorry about that. Now, 6 months later, Earth axis of rotation doesn't change much. And the sun now is seen here. Now, now Northern Hemisphere is in the winter time, and the Southern Hemisphere is summer time. Okay. So it's caused by, so seasons are caused by Earth axis of rotation being tilted with respect to this plane, the orbital plane of Earth around the Sun, that is called ecliptic plane. Explain, okay, that's it. So review these questions, try to get it right. If it's still kind of a fuzzy, just let me know.